Hi, time for another teardown today. This is a mobile chip and pin credit card terminal. This one's got an internal cellular modem, so this is the sort that can be used anywhere. So this is the sort of thing that might be used in things like market stalls, cabs, whatever. Doesn't need a local phone connection. So let's take it apart and see if there's anything interesting in here. Right, nothing particularly interesting on the outside. One minor detail though, the actual SIM slot says remove battery before opening. I don't know whether that's electrical reasons or it just gets really confused and it's to ensure the thing reboots properly if the SIM's replaced. But they're actually pretty serious about this because you can't physically do it without taking the battery out. There is a thing there saying do not remove disconnect battery unless instructed by your help desk. Now a lot of these, I know for example the wired terminals, if you unplug them you then have to get the make a call to actually get them to re-enable. This is mostly about tamper detection, tamper resistance, so that if someone's fiddled about with it, there's a record of it, you can't just open it up, do something, put it back and have it still work. But if we take the battery cover off and take the battery out, this is just a nickel metal hydride battery, nothing particularly exciting here. The SIM slot actually goes into the battery compartment, so you physically have to remove the battery before you can even open this slot. But then that's just a fairly standard SIM module for the mobile modem. Now inside, you can actually see the first of the another tamper resistance mechanism. There's a little plastic post here, and that goes onto this tactile switch down here. So this switch will open as soon as you take the back lid off. Here's the antenna. This is actually a standard cellular antenna. Interesting enough, it's actually exactly the same as the one on the phone that I use. So on the backboard here we've got the GSM or GPRS module, standard module, SIM card slot, and there's just the battery management stuff here. There's power supply, contacts for a cradle type charger, and a socket for a plug-in charger. And this is sort of complete module because obviously these come in different versions, so all the things that are specific to the mobile version, the battery and the GSM comms are on one board. So this version would probably be the sort of thing you'd see on a desk tied to a landline or a local network. One interesting thing I noticed is there's this assembly here. This actually allows you to get a board and a module out without taking the cover off. This is actually like a sort of slot, and there's actually a board in here that you can just about get out, and this has got another couple of SIM sockets. Now this is clearly nothing to do with the mobile comms. I'm assuming this is something to do with the credit card process, and they're just using SIMs as a convenient way of having some sort of fairly easily changeable module. There's sort of two sockets there, one of which is used. There's also footprints for another two. So a surprising amount of stuff on here for just to control a few SIMs, but this is actually designed to be at least, if not end user replaceable, sort of dealer replaceable. This actually is accessible through the slot on the back where you open to change the paper. Not much on the back of this board, just a few sort of various logic chips and so on. There's a super cap there just for memory backup. I'm guessing it may be for a real-time clock or something on the cellular module. Really nothing to write home about on that board. On this side, this is a sort of rubber membrane keypad. One interesting little detail about this keypad though, as well as the normal buttons, there's these extra buttons which just go to solid posts, and there's the contacts for them on the board. So again, this is another tamper detection mechanism, so when the thing's all screwed together those buttons are actually held against the PCB and in contact, so if it sees these buttons being unpressed it knows that somebody's tried to take it apart, and obviously the thing will just disable itself and go into some tamper detection mode. At the top here, this is a read head for the magnetic card reader. It's got the magnetic card reader there, and there's also a slot at the bottom for a chip type card. This looks pretty much identical to a standard audio tape head, although I'm sure it's optimised for credit cards with heads in the right place, but it's exactly the same technology as an old-fashioned magnetic tape recorder. Top here we've got a little thermal print mechanism. Again, this is a very simple mechanism. There's just a little stepper motor for running the paper over this roller. Little cute little gear train on the side of here. Then a full width thermal print head, so this will literally have a thermal element for each horizontal pixel across the paper. that just prints as it runs past, and there's a spring clip here to maintain the tension to actually press this head against the paper. Right, looking at this main board, the first sort of thing I found a little bit surprising is that they've got this big FPGA in here. I was really just expecting to see a microcontroller. I don't really know how much processing these things do for the whole credit card authorization stuff. I don't really know much about that, but it can't really be a great deal of data. So I'm a little bit surprised they use an FPGA here, but it may well be they're also using this to generate all the timings for the printer, which may well be too fast to do on a micro, I don't know. Or that, say, there may be some security aspects of that. Here's an Atmel processor, an 80251 microcontroller, so that's where the software's going to live. Another chip down here, which I'm guessing is a 29F016, so that'll be where the software lives. There's some unpopulated parts here. Now I'm guessing this is for a phone line modem. Just looking at the structure of what's here, we've got this break here, which is for an isolation barrier. We've got this big footprint here, which I'm guessing will be the relay for it to hold the line open. There's actually footprints for two different types of relay, and then there's the second footprint here, which will be I'm guessing probably a transformer type device to provide isolation. So you've got this isolated area which is connected to the phone line, and then this will be probably the modem part of it that's just not populated on this this version. Down the bottom here, this is the spring contacts for the battery pack. One interesting thing, they've actually isolated most of the board. Now this is going to be for mechanical reasons, because obviously these springs are going to have pressure on them when the battery goes in. So I think what they've done is they've just isolated these so that so that when this gets pressed down, it flexes this little bit of board and reduces the amount of stress that's transmitted onto the rest of the PCB. Another little detail on here, these two post mounts where these connectors are at the top of the case, in addition to the internal connection for the shielding, the inside of this is metallized for EMC shielding. There's an additional ring around these contacts. And if you look here, they've got some conductive rubber. I think there's actually it just feels like very gritty, so I think it's a heavily metal loaded rubber. So again, this is another tamper detection mechanism, so that if you unscrew the case, it sees these being disconnected. Because you look, these you can't really see where it goes, but it's clearly not connected to the ground. So these are again tamper detection inputs for the case opening. I've just taken off that carrier board. There's not really nothing at all under here. Another few optional components here. On the other side, this is the printer mechanism. But there's really nothing here. There's the print head itself, and there's a stepper motor. Down on the PCB, you've got a beeper there, and this will almost certainly be the drive for the stepper motor. Doesn't seem to be anything at all associated with the print head drive itself, so I'm guessing that's driven straight from the FPGA. There may be some silicon on here just to convert from logic levels to the whatever voltage the actual thermal print head needs. Right, just separate these boards here. Again, we see another tamper detection contact here. There's a little set of contacts here, and on this piece here there's another bit of this gritty conductive rubber stuff. So although there's actually a connector here that they could use, they've got some additional tamper detection for this board coming off as well. So they're quite serious about not wanting this thing to carry on working if someone takes it apart, which is fortunate, because we don't care about getting this working. I just want to see what's inside it. Not much on the other side of the board. There's this, I'm guessing that's probably RAM, some logic chips, and that's the tape head, magnetic card reader stuff, so there'll just be some analog stuff there to control that. There's no sensing at all of the motion, it's literally just looking for the signal from the magnetic card that gets swiped across there. Right, it's the top board. We've got a display on here. I think it's the Matrix Plus icons type display. That looks like it's stuck on the board with these zebra strips, and there's some LCD drivers underneath there. Battery here for backed up memory. Obviously all the secure stuff here will be held in RAM, and the tamper detection will make it go into a disabled state, and there's probably also some additional stuff where it will just lose the keys, encryption keys and all that sort of stuff when things taken apart. This is the SIM card, not the SIM card, this is the card reader bit. Right, nothing much down here. Just a few logic chips. That's just the keypad. But this is interesting. This section here, I thought it was just a plastic spacer, but it looks like it's some sort of module. This rubber stuff, I think, is actually sticking it onto the PCB. Let's see if we can figure out what this is. I'm guessing this is going to be something to do with security. You know, I previously just cracked that open. Looks like there's at least 2 layers of plastic in here. Alright, this looks like it's some potting or encapsulation. See if we can actually get this thing off the board. Alright, so it's not a module, it looks like it's just a potted enclosure on the main board. So this connector just goes down onto the main PCB. So it looks like, I'm guessing, I don't know if there's another board in there or not. Oh, this is interesting. They've got all these tracks here, so this again is going to be anti-tamper. It looks like there's several layers of these conductive traces bonded onto the outer case. So obviously when you pull the thing apart it breaks a connection, and that's going to be almost certainly something that causes it to dump any security information as soon as it sees these being broken. Okay. Yeah, it looks like that before it was potted this was actually a flexible board, because it actually sort of slopes down around this, so this is obviously something that's just covers over the whole area, and it then gets potted and already becomes part of the encapsulation, so any attempt to take the encapsulation off causes it to break this connection. And again it's even sort of folded around the side here, so it's almost like a sort of security blanket. Yeah, it looks like quite a lot of resin. I'm not quite sure what this rubber strip stuff's for, unless that's just to stop the resin leaking out. I'm not quite sure how this would have been potted. Maybe it was filled. Oh, there's a little hole there, so I wonder if maybe this thing's assembled and they then inject the potting compound in through this hole to fill the cavity up. So it looks like it's fairly well attached to the PCB. Yeah, this is just like a solid layer of potting stuff. I need to apply some fairly extreme measures to get this off. Yeah, you can see it's just pulled the components off the board. There's another chip there, so it's basically there's two main big chips in this area, plus a few other bits and pieces. And there's what looks like the remains of a FFC connector there, which I'm guessing is what this security thing plugs into. Yeah, there's the FFC connector down there. So all this would all have been one sort of piece of flex that would plug into this connector here. Yeah, this chip is Dallas DS5002, which is pretty much the industry standard for secure applications. It's got all sorts of features. The main program stored in an external SRAM, but this is all encrypted by keys that are held on the chip in RAM. It's actually got a self-destruct input pin, which will be tied up with all this tamper detection, which will immediately just erases all the on-chip keys. So although the data would still be in this RAM, it'll be useless because it's all heavily encrypted. So it's pretty much impossible to get anything interesting out of these devices. That's after you've gotten through all the other tamper detection stuff on this. I think a lot of the external tamper detection is more about people modifying the terminal. So, for example, it sniffs the pins that are entered in the card details and records those and transmits it. That type of thing, rather than actually attacking the fundamental security. It's looking at other ways of getting information. Because one of the problems with, although adding chips to credit cards has made them more secure, because in certain countries they still use magstripe, a lot of the chip cards will actually still work through magstripe, and that actually bypasses quite a lot of the security. There's been a few published papers on various attacks based on that. So although the card system itself is secure, the actual administrative side that not everybody's gone over to the chip system has meant that security has been compromised in a few cases. Let's take a quick look at this LCD. I doubt there'll be anything particularly exciting here. Yeah, we've just got a couple of LCD controllers there, and these strips, which combine with these, they're called zebra strips because you just about see the sort of stripy layers there. They're alternate layers of conducting and non-conducting flexible material, so these just sit on here and they're compressed onto the board to make direct contact with the glass. Let's take a quick look at this printer mechanism. So it's a very simple thermal mechanism. Just get this head off. Right, this little board here, which I'm guessing is just going to be a sensor for detecting, there's a little optoreflective sensor, and this is just to detect whether there's paper there or not, so it knows when it's run out of paper. This is the actual head. So the actual ends here, so this is just going to be lots of tiny little heating elements, and under this big blob it's going to be a driver chip, so you can see all the connections going in. Possibly looking at the way they're grouped, I'm guessing it may well be multiple driver chips and then just a few lines, so it will probably just be driven via a serial data stream. So this is going to be sort of effectively shift registers and drivers under here. I'm not sure if we can actually get this blob off to see what's here. This is all on a ceramic substrate on metal, so that all the waste heat gets conducted back to the back to this metal plate and through the ceramic, so that only the bit that needs to get hot gets hot, to make the print on the thermal paper. No, that's not coming off very easily, but and so that's just a stepper motor and a gear train to run the roller.